Good morning, my name is Jessie Donner, and this is going to be a very short instructional support video for one of the tools that I examined in Module 5. This particular tool is called Desmos. It's available both online as an online graphing calculator and as an app that students can download to their device for free. I've basically had each one of my students in my math and science classes download Desmos as a requirement so that they have access to a graphing calculator both at home and at school. One particular use of Desmos that you can use in your instructional practice is as a mathematical modeling tool. So for example, in grade 10 academic mathematics, one of the units that we feature is quadratic functions. At the conclusion of that unit, I usually have students use Desmos to import an image of a parabolic function in the real world and then use Desmos to model that parabolic function as closely as possible. So Desmos is great because images can be shared and it can be used as a collaborative tool between students. So it definitely has some powerful applications in terms of its collaborative properties. I'm just going to do a really quick demonstration of how an image can be brought into a Desmos graph and how you could use a quadratic regression tool to model the function. And so Desmos has the ability to insert an image, and the one I've chosen for obvious reasons is the St. Louis Arch. You can then modify the center of the image by moving it so many units to the right, so many units to the left. And in this case, I'm going to be moving it slightly up and to the right. And again, these can always be modified. So I'm not quite there yet. No, 4 is too much. 3 is too little. But 3.75 seems to be just right. Similarly, I don't really need this to be 6.5. Perhaps 5 will do. And so what I've done is I've then centered the image onto the Desmos graph, and the red line is the standard parabolic function. You can then use the sliders to change the values of the parabola, move it to the left or right, and move it up or down so that your quadratic then models the real-world image. And so in this case, students would be continuously refining their model, looking at it, assessing and doing some self-assessment as to whether or not the model that they have chosen is an accurate representation of the image that they've selected. And so it does take time, a little bit of patience, but ultimately this then gives the students the parameters for their parabolic function, which models the real-world parabolic structure in real time. And so I just wanted to show you how incredibly powerful Desmos can be, especially for students who require visual representations of mathematical concepts. So thank you very much for your time this morning. I hope you have a great day. Thank you.